This is day 2 of the Enterprise Software Development in Python course presented by CompatibL. My name is Alexander Sokol. And before I get started, just a few items to mention. First of all, you may see this disclaimer that we put in the bottom of the slide. So, at the previous lecture on Monday, quite a few people were asking, why we're recommending a particular tool. We had a lot of discussion about, merits of one tool versus another tool. So I wanted to say a few things. So first of all, I hope you can see the text in the bottom. It's just it's blocked for me by Anastasia. Can everybody see the text in the bottom of the slide?
Yeah, the disclaimer is up.
Okay, great. Yeah, it's blocked for me by Zoom, but everybody can see it. So first of all, I wanted to confirm that CompatibL does not endorse or recommend any specific development tool or third-party package. And we do not receive any endorsement compensation, so we don't endorse tools for money, or we don't recommend any specific tools. We simply use the tools based on best practices, and usually there is more than one tool to the particular job. So the tools that we've selected for the course are the ones that the presenter, me, is most familiar with. Because I don't want to be, sitting here and basically looking for a button in a tool that I'm not familiar with. So I'm using a particular tool simply because I'm just used to it. There are usually many others. For example, I'm using PyCharm, but VS Code is just as good and in many ways better. We use particular Git tool. We use particular we use various tools for other things. So this is not the course about specific development tools. This is the course about Enterprise Python. So we're just using development tools and third-party packages to present a course about Python, right? It's not an endorsement. And, with apologies, I will this time probably skip any questions that have to do with, why is this tool better than the other? However, please feel free, and you should ask, in fact, if I'm saying, for example, here's the Python library, right, that we're recommending. So we're absolutely happy to answer any questions why we're recommending a particular Python package versus the other package, because that is directly relevant to the content of the course, right? Unlike things like, one editor versus another editor. Okay, also one more thing. So first day, there were a lot of questions, right? We spent a lot of time in interactive discussion based on these questions. I think it's a great thing, and this is why we extended the time that we planned for today's lecture and for the 2 lectures on Monday and Wednesday next week. So now we're planning 90 minutes, of which there is about 60 minutes worth of material, and about 30 minutes that we hope can go to either optional material if there's time, or more likely interactive discussion based on questions or comments from the participants. So we'll have now more time for answering these questions in an extended way, perhaps showing examples and so forth. So again, so please feel free to ask. And in order to ask questions, just given the number of participants, please type them in the chat. And I will periodically look in the chat, and my colleagues here, Anastasia and other colleagues, will answer some of these questions in the chat directly that they can. And for questions that require response from me, they will alert me by private message, or I will periodically look and answer these questions at the appropriate time. All right, so let's get started, right? First of all, we have a few things left from the previous lecture that I will start from, and then we go to testing and so which has to do with project configuration. And then we'll go to testing and debugging and to data classes. So data classes and the way to write classes that's safer than native Python classes is the primary topic of today's course. So I'll try to go through project configuration and for setting up testing quickly, and then we'll spend time on specific examples. All right, so first of all, packages and namespaces, right? So, I've seen, many of you, did coursework on Python, right? And normally in the coursework, you present a script, you present a Jupyter notebook. But very often, even in, in a bank or asset manager, people use Jupyter notebooks, people use single scripts. And especially with the Jupyter notebook, that normally one would run Jupyter Notebook is that have a bunch of statements there which are executed by by the user in a particular order, and it's pretty hard to for anyone other than the author to figure out exactly how to run it. It's hard to reproduce. So generally, you can create a single script. You can create a single Jupyter notebook. It should be on Git, but it not always is, and usually it does not have tests. But that's not the right way. And even if you're at the university and submitting this as coursework, it's actually your professor, I assure you, will be very, very happy if you do one of these two other project types. Well, for course assignment, probably the second one, right, not the third one. But it takes very short time to set up, and it's actually make your code more reliable, easy to work with, and easier also for others to understand, right? So the second way that I recommend is a small enterprise open source project style of package, which normally has a single namespace. And some large packages even have a single namespace, but especially small ones. Single folder, possibly with a few subfolders. A separate test folder, right? So it should not be the same folder as the main folder, because when you ship the code, when you package it to put in a Python package index in a PyPI repository, you don't want to actually necessarily ship the test, even though sometimes you want to do that, right? Sometimes you don't. So test folder should be separate, and it should be on Git, and it's usually a single Git repo. But for large enterprise open source project, it does not always work this way, because often a large enterprise project, it does multiple things, right? For example, there's maybe a core library. Let's say if you're talking about risk management application, you may have a library for dealing with trades, and you have another library for dealing with risk scenarios, and they are often developed separately by separate teams. So you need a way to have multiple namespaces, multiple folders, such that everything works together, right? And there is various styles of doing that, and the way that we recommend have to do with a Python feature called namespace or implicit namespace packages. And this is described in PEP 420, right? So the larger the numbers, the more recent the feature. So you can see it's not one of these first features of Python. It appeared relatively recently. And what it allows to do is to create multi-level packages that can be next to each other or can be in a separate repositories. And this way, you can have a kind of a consistent naming where there is a basically common hierarchy of namespaces, but each of these namespaces, each of these leaf namespaces at the end, they can live in a separate Git repositories, separate teams can work on it, it can be subject to its own release schedule, this is how you can keep consistency, so you don't just have to come up with completely random names, and that would make it unclear how things are related to each other, but have a clear hierarchy, but not have to put everything in one folder. So that's the first hands-on exercise, and with that, let me switch to PyCharm. 1 second, where is it? It's somewhere here. Okay, there. Right. So here's the way that we set up. And again, that's not the only way to set it up. We just selected a particular style or convention of how to name packages. But the key thing here is that you can have a multiple level namespace, right? So this is the CL folder. And the first level of this folder, 1 second, let me just open it in Explorer so it's easier to see. So we have, this is the root of the Git repository. I recommend to put all of the source code under SRC, or sometimes it's called lib, such that you can put next to it things which do not have to do with source, and your source directory is not polluted by other things. You can, of course, put things inside source because you still have the root namespace, but especially when you have multiple root namespaces, right? So I have root namespace here, CL, which the reason I called it that because at CompatibL we have a common prefix, so we can immediately see that this is something that one of our projects and not a client project or open source project. So when you're working, basically you could base it on your initials or on your employer. We put all of our code in CL, right? And sometimes you also put here, if you're working on a project, on a library and a project using this library, you may have another namespace here. So you can have two next to each other. So then the thing is, once you have a lot of them and also other things, hard to see which one is a namespace package and which one is not. So we recommend putting code in SRC or lib. And then, as you see, our Robert Frost, the road less traveled poetry is in this folder. So it's next, actually, well, it's empty because it's on a branch. You can put other things here which are not source, right? So in source, you put source code. And all of these other packages is what editors create to keep track of cache, Python and PyCharm and so forth. And there's a VM here, of course. Okay, and then under that, you can have your project name again. So I'm demonstrating the common feature of multi-level packages, the way that our convention of naming these packages is you can always change this. It's not the standard. It's not one of the things that you have to follow precisely or at all. But the way that we did it is that next to this project name, right? So in this case, it's Enterprise Python, because this is the code for this course on GitHub, and I will share the link, by the way, at the end of this lecture. It may be project A, project B, and so forth, right? And finally, inside you have core, where the main Python code goes that you ship. Then tests. You can have singular tests or multiple or plural tests where the tests go. And both of them can have subfolders. You also have things like mocks, right? So we don't have any mocks yet, but what mocks do is sometimes you need the resource for your testing that is hard to make reproducible. Like, for example, it may be some third-party API. A classic example mentioned in Python, well, Python not necessarily, but testing, textbooks is a clock, right? So you want to test the response of a clock, but you don't want to run your test in any particular microsecond of a day. So you can have a mock clock that always returns a particular time of day, right? So that's an example of mock. So mock is a class that substitutes some resource, or like, for example, a connector API that has unpredictable or time change, behavior that changes with time, and produces standard response that you can then use in regression testing. And mocks should be in a separate namespace, ideally, because you don't want necessarily to ship them unless you're also shipping tests, right? So sometimes you want to ship tests so the user can test. Sometimes you don't want to ship them so the namespace is not polluted with tests. So mocks is something that is not core, because sometimes you don't want to ship it and you always want to ship core. But also, you don't want to use tests as references, right? That creates all the problems particular to Python and various tools. So you don't want to import anything from tests, right? And you don't want to put them in core. So it's a separate folder. And CMD usually is a good way to have kind of one-off script. Like, for example, configure the database, configure something that you run once, right? So we put it in CMD. Okay, and then here you have the source. And the key thing about implicit namespace packages, so the PEP 420, is that you have to choose that if you put code in something, everything under it should be in one place. So I can have Enterprise Python folder here, a couple of other folders next to it, or I can put each of them in a separate repository. I can even go here, and because I don't have a need at this level, I can put core in one Git repository and mocks in a separate Git repository or a separate branch, right? And tests in a separate branch. But finally, when I get here, everything under here, once you see .py, any Py file, that's it. From there, you have to be in a single folder, right? So that's why you kind of make it a little bit more scalable. What we're using for that is namespace packages. Okay, and with that, let me now go back to the slides and continue. Any questions about this, please type them in the chat, and I'll be happy to answer. All right, now naming and style conventions, right? So, you hear sometimes the word of, someone wrote code that's very Pythonic, right? Or, basically development is very Pythonic versus not Pythonic. Okay, so what's Pythonic? Okay, so of all major programming languages, Python has the most strict and rigid style guidelines that development tools require you to follow, right? And the style guide of Python, which is PEP 8, right? All of the specifications for Python, they start from PEP. The proposals then become law, quote unquote. So PEP 8, you can see that's a pretty early document. Of course, it gets updated from time to time. And the second chapter in this document is named "A Foolish Consistency is the Hobgoblin of Little Minds." Okay, so first question, what is Hobgoblin? Okay, so Hobgoblin is apparently a mischievous troll. And foolish consistency is the mischievous troll of little minds, which I would take it that don't be foolishly consistent. Okay, that's very strange to see in this document, because when you keep reading the document, you discover that Python, Python, the committee that is in charge of Python, actually requires you, well, I don't want to use the word foolish, right? But very, very consistent, right? So most Python IDEs will keep providing very annoying feedback by highlighting style deviations that would be perfectly fine in almost every other programming language, right? So here's a random sampling of rigid but not functional conventions that PEP 8 expects you to follow. Okay, you're expected to use Pascal case, and Pascal case is pioneered by programming language Pascal, many years ago, right? Precursor of C++. So this language, basically each word you start from a capital, right? So it's called Pascal case, right? So Pascal case for class names, uppercase, every letter is uppercase for constants, right? And the snake case, the snake case is the one with underscore, right? So it looks like a snake. Well, at least it's supposed to. So snake case for functions, methods, attributes, variables. Okay, so you will see in Python that some older older libraries or packages, such as unit test, right? So one of the two leading predominant packages for unit testing, one is unit test and the other one is PyTest, right? So these are the two leaders. Everything else is lower, well, not market share, the open source, but quote unquote mind share, right? So unit test uses camel case for function and method names. Why? Well, it's old, right? So it's old, it's wise, tip your hat to the experience and wisdom of the old age, but don't use this older style, because if you write Python with camel case attributes of function names, people will think that you really don't know what you're doing. It's not like in C++, where multiple naming conventions or style conventions coexist, and people very happily use libraries. Some use camel case, some use Python style. Everybody's happy, nobody complains, right? So this is more like Java, right, or C#, where there is the one naming convention, and Python is like that. That's actually not bad. Java and C# do the same thing, so nothing to complain about here. Okay, but what Java and C# do not do, or C++, is that it gets stricter and stricter as you keep reading. Like, for example, 2 blank lines in certain cases and 1 blank line in others, right? And really, it's very hard to remember when to use which, but the editor, your development environment, like PyCharm or VS Code and so forth, will underline it for you and tell you that you've done something really bad here, like put an extra line, right? You have supposed to import different libraries on separate lines, but import classes from the same library in the same line. Even if it's very long, you're supposed to break the line. Gets a little strict, right? And you're supposed to march information when you go to lunch with your colleagues to someone beating the drum. No, I'm kidding, right? So, but everything else is serious. It's really very, very strict, right? So let me show you. Where's PyCharm? Go back to PyCharm, right? So let me open a class. I think so. Let's just open this unsafe class, right? I'll explain a bit later why it's unsafe. Right, so okay, well, let's take a look here, right? So there's a line here, so I put an extra line. Oh, well, PyCharm doesn't like it, right? So what does it say? I'm just trying to put the mouse on it. Okay, so, sorry. Well, okay, so I'm trying to, okay, I'm not precise with the mouse. Anyway, so I'm trying to put the mouse so I see the message. Well, the message will say extra line, you're bad, right? So, okay, so do that, it's fine, right? So actually, sorry, that's also actually bad, but it takes a minute for it to become unhappy, right? So in other words, the tools will complain, right? And some of the tools will complain by underlining. Command line tools will cause an error. So there are a lot of things here that require again very, very high consistency. So that's why this quote about how you don't want to be foolishly consistent, just choose your own style and follow it. Well, in Python it's not like that, right? But in Python also there are some functional conventions, right? And that you have to follow because they change what the code does. And the most famous, of course, and key functional convention is indentation, right? So when you choose indentation is when you shift the text to the right or to the left, right? So indent defines code scope. So in other programming languages, and I'm talking about what everyone here in this course knows, other languages have curly brackets. In Python you have indent. So we're coding Python as Guido van Rossum, the inventor of the language, indented, not intended. It's kind of pun. So a t-shirt with it, right? We're coding as he indented. Okay, well, but there are other things. Like, for example, when you use a leading underscore for protected attributes, 2 leading underscores for private, and then Python will create a name like this one, where it will prefix it with the class name. So nothing is really private in Python, but it will hide it from your derived classes. And tests will only be found. Module name starts from test. Function of method name starts from test. And the class name, if your test is in a class and not in a separate function, will also start from test. Right? So the thing is, you can change some of these conventions, and we do change them, because one of the things that this does is that it creates kind of a very inconvenient sorting, because if you sort in the class browser, if your classes are sorted, you have classes A, B, C, then there's a huge number of classes which start from test on T, right? And then the rest of the alphabet. So it's much easier if you have test as a suffix. Well, also there's another advantage, and again, let me switch to PyCharm. So we changed that, right? And the way that we changed it, and again, this is something that I believe makes sense, right? But it's not, by any means standard or the only way, right? So what we did is that we changed such that the test is a suffix for class name and also for the module name, because what you want to do is to have the module name to be the snake case version of the class name. And I also recommend just putting one class per module, as a matter of, practice, good practice, right? But still keep the function with a prefix, right? So in this case, I think it just sounds better in English. Unsafe class test dot test attribute name, right? You can see that method name is not getting confused or mixed up with the class name, because one has suffix and the other is prefix. And when I run the tests, they execute. Let's just see, right? Okay, the test run. Now, the question, why did they run, right? Why did they find them? Because I have the file called pytest.ini, right? So you can go and overwrite this standard convention. So somewhere in your path, there should be file pytest.ini. In this file, you're saying Python files should have that pattern, and Python classes should have that pattern, right? So I changed it to a suffix. Not all tools are sensitive to that, right? So sometimes generally, the less you deviate from the standard, the better. I think that's one place where it's worth deviating, because then they're sorted properly and they're kind of more, easier to name. So we use this configuration file to change the default behavior. Okay. With that, let me just go back to the slide, right? So the next thing is we're going to have the hands-on session, right? So now that we looked at the code structure, in the hands-on session, we'll be on formatters and linters. Okay, so they overlap with each other, and some of them belong to more than one category. But roughly the 3 categories of formatters and linters are, first of all, syntax linters, right? When you're using wrong syntax, right? In other words, when your code will not run. And one of them is the linter in PyCharm. And that's actually, again, it's important to recognize, right? That's a commercial linter that's built into PyCharm. And at least as far as I know, is not available outside, right? That's what the engineers at JetBrains basically, doing to make people prefer PyCharm. So it has very extensive configuration options. It's a proprietary linter. It's not part of, it's not on PyPy, it's part of the editor. But if you don't want to use it in PyCharm, or if you're using something like VS Code or another environment, you can use MyPy, which is probably of all other linters most similar. And MyPy will also catch a lot of errors. And if you are using MyPy with PyCharm, then you can make there's basically add-in you install into PyCharm. It will underline your MyPy comments. In this case, however, I would recommend disabling everything that MyPy takes care of, because sometimes you just don't know exactly like which tool came up with it, and it's hard to, you don't know, when it complains about something, you have to know which tool complained, so you can look in documentation and see exactly what's wrong. So so when you put MyPy, it's better to disable the corresponding native PyCharm feature. So when you go to PyCharm settings, there are very highly configurable. There's basically go to settings, inspections. Anastasia, can everybody see my screen?
Well, I do.
Okay, great, right. And yeah, are there any questions, by the way, so far? Now that
We are managing them.
Great. Okay, perfect. Right. So as you can see, there are inspections here, right? And these inspections, there are a lot of them, right? And determined statements. So you can see that there are literally multiple hundreds of various inspections. It's a good thing, and it's also a bad thing, right? Because the more configurable something is, the more two people could configure it differently. And someone, basically you may get someone's code and PyCharm will complain for you, but not for them because they disabled it. So your organization can provide a configuration file. So I mentioned in the first day, right, that PyCharm does not really require a project file the way that Visual Studio does, right? You just open the folder and you can work. But you do actually have the ability, for example, to save the settings and share them on Git with your team. So again, so if you start customizing this, I recommend to share it, because otherwise somebody will keep fixing your code or changing your code because some inspection that you disabled is enabled for them, and it's very, especially for those who want every comment to be in the right place. Python is the right language for them because it's so strict. It's very annoying to see an underlined statement, so they will fix it for you. So basically, better to share. Right. Okay. And the PyCharm here will cache some inspections. So in a moment, I'll show exactly what it caches, what it doesn't, but I will do it when we're doing with tests. Okay. So then the other tool that I wanted to show is PyLint. Right. So PyLint is a bit different tool. So MyPy and PyCharm built-in linter, they focus primarily on syntax errors. In other words, they focus on errors that will prevent the code from running. Whereas PyLint, just like its grandfather, the original lint for C and C++, it will give you advice. Now, it will give you so much advice that even the creators of PyLint, they turn off some of this advice and hit the snooze button on it. PyLint has a command that produces a default PyLint configuration file. So I'll show it in a moment. What you do is that there is the file is called PyLint-rc. And on Git, one second, sorry, I just opened the Git tool as well. Right, so let's see, look within log. Right, so this is the log, and there is somewhere a comment here about PyLint. Let me find it. Yeah, so this is, as you can see here, this is the commit in which I added PyLint-rc, which is generated using PyLint minus generate-rc file, and I put here. So PyLint will create PyLint configuration file for you. And guess what? Even in this file, it already immediately disables some of its own settings, right? So in other words, their own default that they generate disable some of the original default that are without the default file. So clearly, some of this is too much because when they produce the configuration file, they already disable some. And we disable more, right? And when we disable more, then we start, really being very successful here. But it's a bit of cheating, right? Because essentially the only way that we're getting clean PyLint, and I'll show it in a moment, the only way that we're getting clean PyLint result is by disabling a lot of the warnings that would normally complain about. In some things and complaints about are, well, I would say more of kind of suggestions. Like, for example, it says too many public functions in the class. Well, I have a data class. It only has data attributes. Is basically purpose is to map or load data from a database. Next lecture, we'll be talking about object relational mapping, namely SQL Alchemy library, and object document mapping, for which we'll show PyMongo library, right? So object document mapping and object relational mapping is corresponding, basically is first is for document databases, and the second one is for SQL relational databases. That's a way to work with the database through classes. And you have classes which are pure data, right? You only have attributes, and Pylint will complain about every such class, saying not enough public functions. Well, that's not really a valid complaint if the purpose is just hold data. So some of them have to be turned off, right? So we'll show what happens when you don't. So for example, so we have this Pylint, right? So you need to specify the file name. You also can configure it to run it on this whole repository. And we will run it here. Okay, so it looks like Pylint ranked our code as 110 of 10, right? But if I disable, and actually, I should show one more thing, right? So if I go unsave class, we go data class, right? It will complain or not complain or mention that there is a to do, right? So that's one thing that I did not disable. So in data class there is a to do, because there is a feature of data class that's in Python 3.10, but not in Python 3.9 that we're using. As I mentioned, we're always staying one version behind the latest release. So I put a to do here, not to forget to enable it, namely the ability to use slots, which Atlas already has, but data class does, as of 3.9 does not, after the upgrade. All right, so now let's see what happens when we go back to Ultra Edit and disable this. 1 second, I didn't open it yet. 1 second. So I need to open the, and I can do it in PyCharm as well, but so go here and we disable, right? So this is where the, any questions, Anastasia?
Yeah, could you please refer to Z1 about linters and formatters?
Just goes quickly. Yeah, do you install linters and formatters globally or per project with VM and so on? Yeah, so per project, right? So all of the, with the exception of PyCharm built-in linter, which is part of the editor and you configure, but you can also configure it. So basically, everything except the PyCharm built-in linter is a Python package. Generally, Python is great and amazing, right? Because everything about Python is also in Python, right? So all of the linters, all of the tools, all of them are packages from the Python package index. You simply install them as VF. And if I look at it, that's an excellent question, actually. I'm glad you asked it. So 1 second. So let me, actually, what? Maybe I should just do everything on PyCharm so I don't have to keep switching. Right. So this is the requirements file. And the requirements file, as you can see here, there is a Pylint. So that's Pylint. This is the black, right, which is the formatter that we'll talk about soon. So the requirements file has everything, and they are per project. When you have a virtual environment, you install it there, and they're local. Okay, now the linter that's built into PyCharm is a little different. It goes by the PyCharm configuration file, so it's also local to the project. It's really not a good idea to make it global because projects differ. But you configure it through a file which is PyCharm configuration file in the root folder. So excellent question. Thank you for asking it. Anastasia, any other questions I should look at?
Now we have figured out things.
Okay, great, right. Okay, so now Pylint RC, right? So let's look at Pylint RC. Okay, so it looks like that did not like it, wrong encoding. Okay, so why the hell that happened? Anyway, I'll use Ultra Edit, so it looks like for some reason it's not ASCII here. 1 second. It doesn't seem to really present any problem here. ANSI, I see. Okay, so I saved it as ANSI late Latin, right? So I probably should have saved it as UTF. Yeah, so it doesn't matter, right? So just to comment, right? So PyCharm doesn't like to open it because it's not UTF. Let me just see if I can convert it to UTF, so we don't have to keep switching between editors. Sorry. To ask it to Unicode. Okay, let's see if it makes PyCharm feel any better. It makes PyCharm feel much better. So let me just connect it to Git and we'll continue. Right. So any questions so far, by the way? Okay, so I'm going to write a commit message saying switched encoding to UTF-8. Okay. No questions so far?
No.
Okay. All right, continue. All right, so what we're going to do here is to, you see this says disable, right? So, well, too few public methods, that's the one, right? So I'm going to just remove everything disabled and let's see how well we do here, right? So that's a real test, right? Oh, sorry, terminal. Okay, well, a lot of things it doesn't like. Okay, so what doesn't it like? Oh boy, it looks like not. Okay, so PyCharm likes UTF-8, but not the, okay, so I'm just switch it back. Pylen doesn't like UTF-8. PyCharm doesn't like Latin. Well, we want to use the code we want to use the code, right? Not look at it primarily. So let me switch back. See if it's any better. Wonderful. Okay, so that's our to do. We've seen it before, right? Missing module docstring. Okay, well, that's one thing that it complains about here. So in module, right? So we have docstring for classes. We have docstring for metas. They like docstring for module in init. Okay, so maybe it's valid, but sometimes it's just you don't want to put the, when you have a lot of init files that are simply empty and indicate there is Python code in the folder. Sometimes it's not really necessary or useful to just go and put all of them. So that's why it's typically disabled, right? So let's look at another class. Let's say unsafe class, right? So what to come out here? Too few public methods, right? That's the one, right? So, well, too few public methods. It thinks, in its great wisdom, that there should be 2 public methods, but there is 0. Okay, well, my bad, right? Not enough public methods. So anyway, so Pyland is amazing, right? You just have to make sure that you configure it so it complains about things that you care about. I will show in a moment that Pyland can complain and find things which are actually quite difficult to find. And I'll do that when we go to testing. But so far, let me just finish with Pyland. Any questions so far before I go to formatters?
No, I think we can proceed.
Okay, great, right. So, and by the way, just before we continue, as you may remember, we're talking about Git, right? So one good practice is never leave anything uncommitted on Git. So I'm just going to make a commit saying back to Latin encoding. Right. Okay, great, right? So now back to Latin encoding. Git is clear, so we can always recover and come back where we were before. Okay, now what is black, right? So black black is not the only available formatter, right? So that's a different category of formatters, and black is opinionated non-configurable formatter. It's not that opinionated, frankly. I mean, it's I would say a lot of things that seems to live the way they are. So when I was reading documentation, I thought that this is something that will format the code. Every single line will be changed. No, actually, some things that when it sees, it remains, it leaves them as they are. But one good thing about black is that it's by design non-configurable, because when you start configuring formatter, everybody configures them differently. And in open source project or in commercial project, black is the choice that I believe is good, because is by design has limited configuration options and is less likely to produce back and forth changes because different styles that you get with the highly configurable formatter that 2 engineers on the project configure differently, or multiple engineers. But other options are also autopipate and YAP. Again, so I'm using black because that's what I'm used to, but you can look into others as well. So let's run it and see what happens here. Okay, so going back to PyCharm, right? So you go black dot, right? And let's see if it complains about the existing code. It doesn't. Why? Because I ran it before, right? So, but let's make some changes here. Like, for example, let's I don't know, make a few lines here, a few lines there. Perhaps we can leave the space here, and let's see if it we save it, right? And then we run black again. Okay, so 1 file reformatted, 14 files left unchanged. Back here, so you see it recovered what we had before. And by the way, as you see, the underlines, wiggly lines that PyCharm uses to indicate to us that it is unhappy now disappeared, and PyCharm is happy again. So black and PyCharm linter have agreed that this is the proper format of PEP8 as it should be. So that's the black formatter, and normally you have them on the bot, right? So normally when you have something automated, you just have a bot make the commit. It's especially bad idea to change the code and then run the formatter that touches any line of code that's not your code, because then you mix the two things, right? So either run it and make sure that only the code that you just wrote or touched is updated, or have commit and then have the bot update your code. But then you have two commits instead of one, so it's not ideal. By the way, black is extremely reliable because black compiles your code into the bytecode and then changes it and compiles again. And unless the bytecode matches, it does not change the formatting. So it is guaranteed not to destroy or change the behavior of the code. Any questions about linters and formatters before we proceed?
Not yet.
Not yet. Perfect. Okay, great. So we're doing well on time. I think we're also doing pretty well. All right. So a typical way to run a standalone script with Jupyter Notebook is to, it's not, basically it's not ideal, right? But usually when you have a Jupyter Notebook, the way that most researchers run it is they repeat the statements in the order that they know is right, but nobody else can figure out usually. And then if you get a good result or you get a bad result, it's usually very hard to reproduce because you run a few things, you get some result. No way to repeat them or be sure that you can repeat them the same way before. So not great, right? Cannot be shared with the team. Hard to document, manual as well. Sometimes you need to run something and you need to take 5 manual steps. Okay, so preferred way to run enterprise code in development and in production. First, in development, right? You need to have an integrated development environment that can execute all tests automatically. And not only that, but it's absolutely critical that your project also has continuous integration server, such as Jenkins, Travis, TeamCity, to run tests on all new commits in selected branches. For example, it could be the develop branch or the main branch, right? So main branch is used to be the name master branch. It's not the name used anymore. So develop or main branches, right? And the right way to set it up is to set it up so it annoys the committer, the person who made the last or the first rather breaking commit, with hourly emails until fixed, right? And usually a good idea to copy the boss so the boss knows who broke the build, right? So in a successful enterprise project, developers who break the build get bad reputation, so they know it's like a bad thing to do. Not, basically, there are some projects I've seen, you'll say, yeah, I broke the code, don't worry, I'll fix it tomorrow, right? So that should not fly in a, successful development organization. And that's what this continuous integration servers do day or night. Also, why in Python everything works so well together, what you do is that you run this test in an automated way against all of the combinations of various versions of the third-party packages that you accept, right? So in your package manager, you say that you work with a range of versions of other packages, and you test with these versions of other packages, such that no matter what the user of your package installs, what combination of third-party packages, because the requirements it says any version after this version. That's the usual way to do it, right? So you should test with the new packages, the old packages. There are some very obscure bugs that appear, especially with math code. So you need to make sure that this continuous integration testing goes on and uses all kinds of integrations and so forth. So you always know it works well. All right, so there is a question. Let me just stop for a second. Is Windows required to use it compatible like the company policy? And what if developers use different systems to work on the same project? Okay, so well, this course is not only about compatible, but no, Windows is not required. You can use Linux. In fact, many projects use Linux because cloud runs on Linux. And with math, often you need to run math on the same operating system as you run in production to make sure that everything works correctly. It's supposed to work the same way in Windows, but it does not always for math because math is different basically Indian differences and so forth on CPUs as well. So yeah, I mean, you don't have to. In fact, Python is great because other than for some very specific math libraries that are prone to kind of instabilities that will produce, like machine learning is one of them, unfortunately. So some math libraries or math algorithms, they can they have bifurcations, right? So they produce different results depending on random factors. But 95 or 99% of Python code you can develop on Linux. Somebody else can develop on Windows. It will all work together, and it's actually even good because you will know that if you're developing only on Windows and nobody ever run this on Linux, except the continuous integration server, which always does. Then you may overlook certain things that developer who is developing on Linux would know. So yeah, absolutely, it's no problem to use Linux. In Python, everything works, and people can use different operating systems. Not a problem at all. All right, so let me just continue. Right, so now preferred. Okay, so second thing about testing, right, is that some tests, in order to run them properly, require a lot of time. For example, math tests, machine learning, right? So in order to make sure a machine learning algorithm works correctly, you need to run it, and training usually takes time. So we normally deal with this, and that's a good way to do it, is using a global quality setting. So the global quality setting, and you can simply set it, basically make a class in which there is a class variable with the setting. So this quality setting controls the trade-off between how fast the test runs versus how accurate is the result. And when you set quality to 0, then it becomes the smoke test, right? So smoke test is actually, I'm not even sure what the origins of it are, but I assume you make a stove or something and see smoke is coming out in the wrong places. But essentially, smoke test in QA is a test that you run very quick test to just make sure that everything, the basic things work. So the key thing about smoke tests is they have to be extremely fast because you want to be able to run the test suite in seconds, ideally, such that every time you write code, you just quickly check if you broke any tests. Right, just like you saw this 20 tests that we have, run in a second, including the setup, right? So, however, for math, for machine learning, other types of mathematical calculations, especially, sometimes, or for example, when you have tests which test database under load, right? So you try to load a billion of records or terabyte of data and see how long it takes or if it works. So these take longer. So if you have a quality setting, you can set it to 0 when you develop, and everything will run fast. And some tests which cannot be made fast, they will just be skipped. And in a continuous integration server will run high level of quality. And depending on how much time you have for the test and what quality you want, you can change the quality. So you can have, for example, 0 is a smoke test, 5 is the default. If you want some very precise testing, for very heavy loads, you can make it 10. If you want something better than smoke, but not the full default, make it 1 or 2. So global quality setting is the way to control testing. So we have the same tests that run different amount of time. And for math, it usually has to do with things like how many Monte Carlo samples or how many iterations in the machine learning optimizer. For example, so you can control it and still have faster, because if the tests are very slow, then developers will not run them when they develop. And when they find a bug, they will have to spend time finding out exactly when it happened. So testing that it can be effortlessly repeated often is very important. All right, and in production, the way that you want to run the code is command line interface, or CLI, right? It's a pretty ancient but still popular way to run code. And given new life by the cloud, because the cloud, a lot of stuff you do in the cloud is just a 70s Linux commands, right? So and approaches. So CLI is command line, right? So it's still very much alive and used for cloud technologies. For example, AWS primarily way to interact with it is the CLI. Stateful REST, right, is when you make a REST call. Make a call to the API, Web Services API, and you pass the some parameters to the call, but it takes data from a database or a service and pushes data to a database or service as stateful or stateless when all inputs and outputs are by rest. And that type of calculation, which is stateless, is more scalable, easier to in the cloud. It's easier to implement it in a cloud, right? So it's preferable. And there's actually quite a interesting discussion there, but we should keep moving on because that's not the primary purpose of this course. Any questions so far? Testing and so forth.
No, please proceed.
Okay, great. Right. So now the test that we will show written using PyTest because it's a newer and more Pythonic framework than unit test of the two leading ones, in a library called approval tests. In this library, it's probably the least followed from all of the libraries that we're using here. It has a kind of a smaller following. I think it should have larger following. And again, as I mentioned before, we're not, I think it's a great library. We're not being compensated for mentioning it. But also, you can implement approval test methodology without using the approval test library, because all it does is that it produces some sample output and then compares to it. So it's a way to do regression tests easily than with a normal kind of unit test asserts. So you can do it yourself. It's not what I say, like, don't do it at home, right? You can do it at home, but we're going to use the library for that. So let me switch to PyCharm and show what we're doing here. So first of all, let's look at the test folder, right? So it's in the test folder, and just make sure I'm current on Git. Hold on. Okay, I'm current on Git. That's good. Just push it. All right. So let's take a look at the others class test. Let's look at unsafe. Let's look at some unsafe test, right? So, and again, I will soon tell you why I call this class unsafe, right? Or rather, it will become evident. Okay, so let's run this test, right? And this is the normal kind of a unit test, right? And we will, I'll set the breakpoint and I'm going to execute from here on the debugger. Okay, actually, it looks like I was already debugging, so I'm going to stop and rerun. Okay, so I'm here, right? So I created this unsafe class, right? It has a few attributes. And I set an attribute. I set an assert here, right? So I'm asserting that this is equal to 1. When you're running a when you're inside the PyTest driver, the assert in Python will not do what the normal assert does, right? So normal assert will give an error, but this thing will actually basically substitutes when the PyTest run launches, it substitutes the assert and changes a lot of the behaviors. So this will actually, produce a test error as opposed to what normal assert does. And assert succeeded. The other assert succeeded. Okay, great, right? And now actually, well, we're back in the harness. So this test was successful. Anybody notice anything? Okay, so did anybody notice like anything wrong with this? Sorry, 1 second. So let me just show you the class itself, right? So you can see. Raise your hand, right? So we normally would do a poll, but it takes a lot of time, right? So you have this class. Remember, unsafe class, right? This class. This has 2 attributes: int attribute and list attribute. Did anyone know anything wrong with this test? Anything funny here? Raise your hand please raise your hand in Zoom if you see anything wrong. Anything that's not, kind of out of the ordinary here.
4 people.
4 people. Okay, good. Okay, right. All right. So great. All right. So 4 people. Right. So have noticed that there is a typo here. So I made a class, right, in which there are 2 attributes: int attribute and list attribute. In a test, I created the class. I created the instance of a class, rather. I set the int attribute, but I made a typo. You see, it says here attribute. It does not say attribute. There is a typo. So in the class, this attribute is set to 1. in a test, I was going to set the attribute to 2 and test for it, but I made a typo. So now my class has 2 attributes. One with the correct spelling that still has the old value of 1, and that's what I'm checking here. In another one with the incorrect spelling that has the value of 2, which was created by this test. In Python, class is a dictionary unless you use something like slots or unless you use one of these data classes libraries. In this, by the way, I'm still talking about testing, but this brings us actually to the main topic, data classes, right? And why normal classes are unsafe and why data classes is a better way to write classes that focus on representing data, but also, I believe, also all of the other classes. So normal Python class, and this is good for things like querying dirty, just try it, basically do it, right? So, when you're too lazy to be careful about the types. Essentially, it's a dictionary. So if you assign the attribute with the wrong name, it just creates a second one. And that's a fertile ground for bugs, because you may assign an attribute that does not exist, has been deleted, right? So for example, a class creator could delete the attribute or rename it, right? But your code will still execute. So actually, it's not very safe, right? And the thing is that the larger your project, the more likely these errors will eventually bite you. It's only in very small projects, a single file, a few files, that you normally would prefer kind of the speed. Actually, I would never prefer it, right? I want to know that I'm not mistyping the name of the attribute. But in default Python, that's what happens. So now let's see, how we can, that's basically how the search works, right? So now let's go back to the linter, right, and see if PyLint will notice it, right? So I'm going to go to the terminal. 1 second, I need to move the Zoom window out of the way so it's not blocking the terminal, right? So let's go to terminal. Let's go to a terminal and let's try to run PyLint now on tests, right? So I'm going to run it on tests. Classes and save class test. Okay, let's see what happens here. Missing module doc string. Oh, I'm sorry. I need to. Okay, yeah. No, sorry. I did not configure. Forgot about this. I did not configure the path for PyLint to find it. So what I'm going to do is I'm going to take this whole code and just put it together with the class. 1 second, just temporarily. Okay, so I'm just going to execute it here. I know that's not where it belongs, but just do it, right? Underline, because they will want me to leave 2 lines, right? Okay, so let's see if it executes, right? It should, because Python is perfectly happy for me to create the second attribute. And let's now try to see what happens if I run PyLint. Attribute, int attribute defined outside the net. So there, right? So you see how useful it is, right? So PyLint actually found it. Okay, so that's one way to do it, right? Well, the thing is, PyLint found it here because it was just right there with the name. There are a lot of situations where this attribute name is actually inside some function and so forth. So PyLint found it in this case, but it will not find it in other cases. So, very important that these bugs are prevented. And there are several ways to prevent it, right? So one of them is something called the slots class, and the other one is this libraries that we'll talk about in a moment, which are, attrs, data class, and Pydantic, right? And they all kind of do the same thing with various, slight differences in purpose and functionality. Right? Any questions so far?
Not related to the material you're discussing.
Okay, perfect. All right, so now let me close all of this files, and I will go back to Git and get rid of the change. So I would want to commit and make sure that that I am current on Git, so I can easily recover. Right. So now I'm back to my regular class. Okay. And now let's look at other type of testing, right? So we're almost done with testing, but not yet completely. So there are a couple of things that else, right? There are a couple of other things. So first of all, we already look at regular assert, right? But there are also asserts which have to do with, which essentially the assert that an exception happens when you want it to, right? And the way that this is done is here. So this is a class in which the same type of error, you see there's the same type of here, will not happen. How do we test that the system or Python will throw an exception or raise an exception rather? How do we test that the Python interpreter will raise an exception when we want it to, right? When we intentionally provided a typo. So the way you do it is that in Python, there is a feature that you're familiar with if you're familiar with the syntax called the context, right? So context is you say with something, column, right? And everything here happens within that context. And the context that you want to use here is pytest.raises attribute error, right? So if I do this, it will raise an attribute error. Let's see. You see, attribute error. Our class object has an attribute, has no attribute int attribute. What I want is to, that's the right behavior. So I want the test to pass. So I say with raises, and this will test that the exception is raised. If the exception is not raised, in this case, there will be an error, right? Let's assume it's 1. In this case, it will actually, oh, sorry, equal 1. It will actually pass. And sorry, 1 second. Oh, I know, sorry. It's not the value, right? It's the typo here. So that should raise an exception because the exception did not happen, right? So in other words, the test failed because it was supposed to produce an exception, but it did not, right? Did not raise. That's the way to do exceptions, right? Let me just interrupt for a question. Is this the reason why programmers use setters and getters? No. Well, okay, yes and no, right? So setters and getters are or properties, rather. So setters and getters are functions that set or get a property. And when you have a property, you in fact, can provide some custom checking and so forth. But in Python, when you have a property with a particular name and then you mistype the name of this property, exactly the same thing will happen, right? So if you have the property, if int attribute was not an attribute, as the name suggests, but a property in Python, and I mistyped it, Python would say, okay, it's a new name. I am probably trying to create implicitly an attribute, and it will happily do it for me unless I take explicit step not to. So making it a property would not help because property versus attribute only affects what happens for that name, right? The correct name. But when Python encounters the wrong name with the typo, it will treat it as a new attribute anyway. So there are all kinds of good reasons to use properties, more so in other languages than in Python perhaps, but that's not one of them, right? So making a property will not, very good question also, but the answer is making the property will not help. Okay, so the last thing that I wanted to show, and let me just recover and go back to the original Git just so we don't get errors unnecessarily. Wait 1 second. So I'm going to go discard and go back to original code. Sorry, I need to be on PyCharm. Right. So last thing is that I wanted to show is how to use approval test. Okay, so what's an approval test? Suppose that your correct result is a complex result, like for example, maybe some matrix, right, or some large mathematical object or some large JSON file that you want to make sure the code produces. But this JSON file is or string or large string or matrix or whatever it is, right? It has a lot of elements, right? It has a lot of code. So you don't want to be saying, if it's a matrix, right? You don't want to be saying assert element 1 is equal to something, assert element 2 is equal to something. So in a lot of cases, the result of your test is some correct answer, right? A sample of the correct answer. Sample, it's probably a bad word because it's used for other purposes. right? So not a sample, but say, I don't know, basically the perfect, the perfect answer, right? It's the correct answer. So I want to simply save it and make sure this answer is produced, right? So in other words, I already verified that the answer is correct, and I want to produce a regression test, or rather non-regression test, right? So they call regression test, but really non-regression test. I want to make sure there is no regression. I want to make sure the same answer is produced. But I don't want to write this complicated asserts to check each element inside this answer, if it's a complex object and so forth. So that's what approval test does, right? And the way it does it in this particular library, and again, you can do it at home, right? You can make your own because it's so simple. Let me just find it quickly here. So it's a function is verify, and let's look at, for example, this address class here, right? So we're using something called wrapper, right? And let me go back. Oops, sorry. Go back to the class itself. So what is wrapper, first of all? Wrapper is the and here when I have slots class, I actually have to produce it myself. So wrapper is what you see in the debugger for the class. So when you define a function like that, and that function returns a string, and by the way, I missed the opportunity to be even more Pythonic here and specify the type, right? So we can do that. So this function returns a string. Actually, you know what? Just go back here. I don't remember if actually Pep wants you to. This is sorry. Normally for a function returning string, I would put the return type. I don't remember if for wrapper they want you to or not. Maybe they do, but let's just leave it as it is. I'll check later. So a wrapper is the way that the class is represented to the debugger, because otherwise it's going to look extremely ugly, right? So let's just take a look here in this test first, right? Okay. So unsafe class test. So I'm going to run it again and stop in the debugger. Okay, so I go obj, right? I think just got a couple more steps. So we set the attribute, right? I go obj, right? And you see it says, unsafe class, with some, complex data, right? So essentially, when you go in the debugger, you cannot really see easily exactly what's inside the object, right? You can actually drill down, right? And then, it will be more helpful representation. But when you just click on the debugger, you don't see kind of a simple string, right? Or when you go, error message in this object, there is an error, and put it, the value inside the string, it will not produce anything meaningful, right? It says, unsafe class and some address, right, where it's stored in the Python interpreter stack, right? Okay, so if you do wrapper, it will look better. Let's just look at unsafe class test, right? So if you go unsafe class test, or sorry, slots class test, then it will look like this. 1 second, let's just run that in debugger. Okay, so now it will look better, right? This is int attribute is empty, list attribute is empty. So that's because I defined this wrapper, and address will also define wrapper. And I want, in this case, test what the wrapper is. But I don't want to, it's a complex string. I don't want to type and repeat the string. So what it does here is that I write verify. Let me see what happens when I run it for the first. When I run it for the first time, let's go to the folder. Accidentally muted. Okay, so I'm back online, right? So when I go to the folder and I go to test, right, and I go other test. So this is approved file. So let's just delete it for a second and see what happens. If we delete it and then we run, I will get an error. And the error is saying that I did not find the correct answer, right? So it says approved file. So there's a result that you approved and the result that you received. If it does not see the result you approved, then it's considered to be empty. In this case, it will produce the results I received, right? So there's approved and received. So what I need to do is I need to look at the diff between these two. And I can see that this one is empty because I deleted it. And this is what it was produced, right? So that's the wrapper that produced the representation that produced by this address library. So I'm going to save the same thing in the approved file. So I'm going to save this thing. So now I have the approved file and the received file is the same, right? They're identical. And I will run again. So when I run again, it will find the approved file. So it will produce the received file, compare to the approved file, and get rid of the received file, right? So it only saves the received file. It creates a temporary file. If it's different from approved, it keeps both. So you can see what the difference is. And there is something called compare, where you can make it interactively, basically open an editor and compare it for you. By open basically a diff tool manually, right? You can also make this library to do it automatically for you. I don't recommend it because you don't want to have your Python code opening interactive windows for no reason, right? Because it may happen on the server, for example, when nobody is there to click it away. And actually, I've seen code crash because it just kept opening the windows on unsupervised server until it crashed because it ran out of memory. So, so you don't want to configure this approvers, right? But that's a great way. So this approval test concept, right? That you save your result and then your test compares it to the new result, and there is this approved file to see what exactly what it should be, right? So that's what it should look like. It's a great concept. I highly recommend using it. And you can use it with this library or without this library. Any questions? Can you repeat, please, what is the approval test and how it works? Okay, so I think this question was asked before I did. So I'm just going to skip it because I did just literally did that before I saw the question. All right, so so let's continue. If there is still any question, please ask in the chat again, and we'll go forward. All right, and finally, now let's look at these classes. We're doing well on time. I have 15 minutes more left of material, and with that, again, we're going to data classes. You should already be familiar with type annotations. They're used by data classes, again, because this is enterprise Python course and not a course in basic Python syntax. I'm assuming that you're already familiar with them, but I will also just quickly rehash, to basically as a reminder what these are. All right, so let's assume that you need a class in which you have two attributes, int attribute and list attribute. That could be a class in which is specifically for working with data. That the purpose of which is to hold the data with no functions, or it could be a real class. So this approach that I will talk about, which is data classes, right? And we'll talk about one way to do it manually and 3 libraries for doing it automatically or simply in a simpler way. I believe that this is the right approach for any class, because with the normal class, there are so many things that you need to do manually to make it work properly, in so much danger that when you add an attribute, you then have to go to like 5 different places to fix something, or the default behavior will not make sense. That I believe that working with using essentially this data class approach is a good idea for any class. I personally use it for any class because it does a lot for you. And you need it just as much when you work for when you're using any class, and not just classes specifically for holding data. Okay, so what does it do and how does it work? Okay, let's look at the first unsafe class. Why is it unsafe? We've already seen it, right? So it's unsafe because it's a bag of attributes. It does not control the name of the attribute if you mistype it, or if you correctly specified it, but then after that somebody renamed it, your code will continue to run, but will not do what you expect, right? For example, we'll tell you maybe, you're building a security system, trigger the security alarm, but the field is different, it will not work, right? Or, open the parachute in your Mars lander, and the function for opening the parachute was actually renamed, and it will not open, right? So is unsafe, right? That's why it's unsafe. It's simple, right? So, all you have to do is to create a init and assign self to these attributes. If you do it here, by the way, this will be class attributes shared between all instances. If you do it here, they'll be specific to the instance. But there is no way it's not safe. You don't have any way to independently check that the name is correct. In the type, also, if you have the wrong type, nobody is there to help you. Okay, so there is a manual way to do it, right? And there are several aspects to it. So first of all, oh yeah, and a couple other things that are bad with the unsafe class. So let me just run the test here. So first of all, one thing unsafe class does not do correctly is comparison. So unsafe class is unsafe because there are many things that the class should do, which by default Python class does not do correctly. And this is because Python acquired more and more advanced language functionality after it already was a used language. So I think that the Python committee and Guido van Rossum did an amazing job of evolving Python without breaking the existing code. But you can see that some compromises were made, right? And one of them, well, some of them are these default behaviors, which you cannot change once there is existing code. Your rocket is already flying to Mars, right? You don't want to, or is ready to fly, right? You don't want to just change the way that it's treating things like comparisons, right? So unsafe class does not check attributes names, does not check types. Equality operator is not defined correctly. So once you start setting it all up, it requires labor. And one way to do it is manual, right? So slots class. So the way that you define the slots class is, let me just go back to the definition. First of all, you define the attributes in three places. First of all, you define them where you used to define them, self.int attribute. If you don't do that, there will not be instance attributes. They will be shared between all instances of a class. There will be sort of like in C++ or Java or C#, they will be static as opposed to instance variables. Here there will be class attributes instead of so same thing, different terminology, right? So this one, if you don't do that, right? If you delete that, they will not be different for each instance. But you cannot put the type annotation here. That's already body of the code. So there's a second place you have to put the type annotation. So I'm going to say that this is integer and this is list of integers. I want to do that because I'd like to know if I'm trying to assign a string, it expects an integer. All kinds of bugs can result if I don't take care of that. But I cannot do it in the same place. Okay, but if I want to know if I assign the attribute with the wrong name, there is actually a way to do it in Python. It's called slots. And the effect, it also makes the code faster. What this does is that instead of having attributes which are in a dictionary, it assigns to them kind of more like in languages like C++ or Java or C#. It assigns to them specific slots, or in other words, it does not become a bag of attributes. It becomes more similar, even though not completely, to like a normal class, where in C++, of course, if you mistype the name of the attribute, the code will not even compile. Here, there's no compilation, but it will not run. In the linter will be more likely to complain and alert you to this. But okay, come on, right? 3 places, right? So you have to put slots, you have to put types slots here, right, with the names in quotes, types here, and assign to self here. So it's ridiculous. I am repeating it 3 times. So if I have 20 attributes and I'm adding the 21st, I go here and I have to go in 3 places, right? And then I go to wrapper and it's a 4th place, right? So now I need to create wrapper manually. So I do here. I did not even create the comparison or equality operator, but I would have to go and take care of that new attribute for the equality. And if I need more or less, right? If I need ordering, I'll need to do it as well. So if you start doing it manually, like in the slots class, I did probably about 10% of what you really need to do in full, what these other libraries do. It just becomes extremely labor intensive. So you can do it, but you don't want to, right? There's an easier way. And the easier way is these libraries, and there are many of them, but the one that we selected is Otters. That's the grandfather of this approach. Then Otters, older version of Otters was adopted and incorporated into the Python language as of, I think, Python 3.8, and became something called data class. But Otters team continued to evolve the library. So there is Otters inside Python called data class. There is Otters separate, which is is Otters third-party package you can use instead of data class. And there is something called Pydantic, and Pydantic, you can either make data class do Pydantic validation, or you derive, right? So these two you specify through the declarator. So declarator when it imports the class, it changes your class before it gives it back to you, right? So decorator is something that takes a class or a function and alters it before you're using it. So that's a way in Python to basically change the default behaviors. So attrs uses define. Old attrs use different, decorators. This one new version of attrs uses the. I think there's a question I'll answer in a second. Nastya, I hope it's not again.
Well, it's about data classes, so just
So basically those data classes protect you from implicitly creating new properties and not use. Yeah, exactly. So that's one of the 15 or 20 different things they do, right? So yeah, excellent question. Yes, but they also do a lot of other stuff, right? So but that's one of the things that they do. In fact, rather they help you do it if you want to, because some of them by default don't, right? So in other words, they basically help you avoid repetitive code where you have, when you add a new attribute to the 20 you already have, you have to go to 5, 10 different places in the code and add it everywhere. And if you screw up, well, first of all, it's labor intensive. It's not really exactly creative work or enjoyable, right? But also it's very easy to make a bug. So now some of these libraries by default prevent you from creating these attributes with wrong names, and some of them don't. And some of them make it optional behavior. But the key thing they do is that they prevent you from having to go to 20 places and change each one of them if you are adding an attribute, right? So they automate this process for you through the decorators and through the base, right? So Pydantic does it by default by deriving from base model, data class and attrs through the decorator. Okay, so how does it work? Like, let's look at attrs, right? So attrs, there are several ways of doing it. Several ways to syntax. So I'm using the latest syntax. And the way you do it is that you specify in attrs, you specify a static attribute. And it will then, through its magic of the decorator will make it instance attribute by assigning self to it, and basically doing all kinds of decorator magic. So I'm saying this int attribute is optional, and the type is int, and the value is none, right? So that's the type annotation, which again, I'm not covering here during the course because that's not enterprise Python, that's just normal Python. You're specifying this optional attribute of type integer and with the default value of none, right? So if I remove that, it will not let me create class without specifying it. This is the list attribute. We should go this one, list attribute of the type int. And this is the list attribute with the bug, right? So, okay, so now what is this? What is the with the need bug here? Okay, so because attrs has to work together with the core Python, and they do not have the benefit of changing Python, they unfortunately suffer from some of the Python behaviors where basically, you may be familiar with this behavior when you specify something like list or any other mutable object as default argument to a function. All calls of the function will share it. Well, guess what? I mean, the same thing happens here, right? So if you do that, all classes will share the value of this list because it happens for static attributes, and attrs creates instant attributes by decorator magic from static. So what you need to do is this, right? So that's kind of basically not the right way to do it. Okay, for data class, actually, interestingly enough, right? Because they are Python, right? So you can specify it here in this way, right? But some of these bugs like that, basically, they some libraries have them and some libraries don't, right? So like for example, Pydantic. Sorry, correction. Sorry, data class still has it. Actually, it's something else that they fixed that attrs couldn't, right? So in data class, same thing, right? So you have to specify factory of list as opposed to just a list to make sure it's different for each class. In Pydantic, actually, it works correctly. Apparently, when you don't, even though I would, still probably, for safety, do it. And other than that, right? So there are a few pitfalls like that here. But generally, the way that these libraries work. You can change factory to lambda. Yeah, so there's a question. You can change. So there's a syntax for changing the factory to lambda. And by the way, data class has absolutely tremendous flexibility and the ability to specify validators through lambda, initialization through lambda, various, do you want init, do you not want init, do you want the value to be taken into account in wrapper or comparison? So all of that is highly configurable. We will discuss some of it. And by the way, we're almost at the end of our 90 minutes. We will discuss, so this is just the beginning. Essentially, I'm presenting the concept. Next lecture, we will be using this concept, and I will actually go to some of or many of this configuration options, including I can show how to use Lambda. So let me defer it until the next lecture, because there it would be actually central to using them for object relational and object document mapping. So the address class, right? So maybe just come back here. So maybe just go to data class, right? So data class is the data class, address library, Pydantic library, and data class feature of Python all do the same thing. They help you avoid repetitive code when you have class with attributes. And I believe it's a great idea to just use it for all classes and not just the classes of purely holding data. Why not? I mean, it helps you create classes that have the right behavior. Most of it is completely very helpful and self-explanatory and works exactly as you expect, except for one thing. They all suffer, well, most of them suffer in various ways from this issue with Python. That's the issue with the core Python, that once they did it in a particular way, unfortunately, they really cannot change it. And that issue has to do is the same issue that in core Python, I'm sure you learned in a Python course, that if you provide a default parameter to a function, which is a mutable object like a list, right? Mutable meaning it's not a value that you cannot change like a double, right? Or a string in Python is immutable, but like a list or a dictionary, it will be shared across all instances because it will create a single object and pass that object as default to all of the function calls. So if you add an element from one function, from another function, it will have a lot of elements. So it's the same thing, but revealed in a different way. So in others, if you do this, it will be back. That's what it says init back, right? So if you do that, it will be shared across all objects, and the test proves it, right? So there's a test here that proves it, where we create that class, we append one to this attribute and that attribute, right? So one was created incorrectly. That's the one with the init back, and the one correctly. Then we create a second instance, and this test proves that the second instance has already length 1 because it's shared with the other instance. So this attribute created incorrectly with that instance shares the list with the other instance and already has 1 element. And this one is created correctly, has 0 elements, right? So correct way to do it is in others is by using this factory and pass type to it. Okay, in data class, if you do that, the same problem exists, but your code will not run, right? So if you do this, your code will if you you have to do the same thing. It's just syntax slightly different. It's a field of default factory of list. Same thing, slightly different syntax. But in others, if you do that, the code runs. Here it will say, 1 second, I just so you see it's underscore thread, right? So in data class, it will actually, the compiler, well, Python will stop you. Invalid definition or usage of data classes, right? So Python here and PyCharm stop you from that. That's because it's part of the language, right? So with the benefit, the Python committee could change the interpreter to warn you about this problem. They would not do it for third-party library, but they did it for the Python feature. Okay, now Pydantic somehow was able to sidestep it. Actually, I'm not quite understand how, but I marvel at the result, right? So you do this in Pydantic, there's actually no bug apparently, right? So so in Pydantic, this problem apparently does not exist. Maybe because they don't use the decorator, but they derive, right? So this could be one difference here. So to summarize, we're at the end of the lecture. Data classes is a group, right? Including data class library, which is part of Python. Address library, which is a third-party library and started this whole concept that they were the inventors of this idea. And Pydantic, which is the third library, and that's the default way to do validation for the fast API, which is the leading way to do REST APIs, cloud APIs. And we'll talk about lecture 4 about that. So that's why it's also here. provide an easier way to create classes where you don't have to do what's called dunder or repetitive boilerplate code, where you have to add new attributes to 10 or 20 different places in code, compares, string converters, all kinds of other things, JSON, reading JSON, writing JSON, and so forth. So I recommend it for data classes. I recommend it for everything else. And answering this previous question, and that will be the last thing in the lecture. So does it help you with slots? Well, it does if you want it to, because Others uses slots by default, right? So Others has the default behavior with slots. I think you can turn it off actually. You can definitely turn it off in the old API, I think in the new one as well. In data class, slots are not default. And in Python 10, you will be able to do that, right? So you will be able to specify slots true, but not in Python 9. So in Python 9, you cannot do it yet. So if you go to the test for the data class, it will have the same bug, right? So there's a test here that proves that it has the same bug as the unsafe. So data class is unsafe in that sense. If you don't specify slots, and you can do it only as a Python 3.10. And Pydantic, is stopping you from that, by default, as well as proven by its test, right? So it raises the value error. So to summarize, data classes are helpful. There are many libraries for them. We reviewed 3, or rather 2 libraries and one decorator, which is part of Python. In the next lecture on Monday at the same time, remaining lectures will be 90 minutes. We'll talk about working with databases, relational through object relational mapping, SQL alchemy, and document versus object document mapping using PyMongo adapter and the Mongo document database. So with that, last set of questions, and this will conclude today's lecture. Anything else? Questions so far? I don't see any.
Not anymore.
Okay, perfect. So with that, we'll conclude for the day. See you everybody on Monday. Thank you.